Topic 5B, weather relationships and weather variables. When it comes to weather, you obviously have noticed that weather is very hard to forecast. Even people who are very good at it and highly trained in it have their issues. Not all forecasts are correct. And it's very complicated. A lot goes on in the atmosphere at different levels with the different interrelationships of weather systems and such. So we're going to simplify it as much as we can, and it'll make it seem like weather is super simple. Why can't everybody do it better? But we're going to look at 4 key things, and we're going to build from there. It certainly is not an all-inclusive analysis of how weather forecasting is done, but we'll start with the basic relationships, which allow you to interpret and understand things much, much better. We're on meteorology still. 5A was insolation. Now we're talking about our weather relationships, specifically the weather variables. So there's 4 key weather variables used to track and record weather conditions. These are the things that you'll almost certainly would hear on any weather forecast. Now, with weather, there's some very specialized equipment, so you do have to know the terms for those very specialized pieces of equipment. Some are obvious and some are less so. So the first one is one of the obvious ones. Temperature is a necessity when it comes to weather. If for no other reason, then it'll tell you what to wear when you go outside. So you measure temperature, of course, with a thermometer, and thermometers come in a lot of different flavors. There's the liquid-filled ones. There's, like on the screen here, the one, this is one like you might hang on a wall of a barn or outside on the garage that has a spring on the back of it. There are digital thermometers, which use the properties of resistance changing with temperature to tell you a number readout. Here in the U.S., we typically use Fahrenheit, though in the reference tables you will also see Celsius. And given the fact that we live so close to Canada, we often hear Celsius on news and media outlets as well. So it's good to understand at least a basic normal temperature conversion. Pressure, specifically air pressure, or barometric pressure. Air pressure is measured with a barometer. And I have one on the wall in the classroom that looks kind of similar to this. These also come in digital and analog versions with needles versus numbers. We'll look at a couple different examples of these when I'm there. But they all have to measure how much the air is squeezing down on you. Now, we are born obviously here on Earth, where we have air always around us. Without air, you don't really care about much else because you're suffocating. But under normal conditions, there's over 14 pounds per square inch of pressure pushing all over your body. And we're just used to it. That's what our skeleton and our muscles interact with on a daily basis. And so the way these work in a lot of cases, in this particular one on the right where my pointer is, there is a hollow metal pancake-looking thing. And there's no air in it. So when the air pressure outside gets larger, it pushes down on this and flattens it some, which in turn moves the mechanism to move the pointer. If there's less air outside, if there's less pressure, it will expand outward more and again move the pointer. So that's one way they can work. You can have liquid ones that change the level based on the air pressure as well. Now, the units for barometers are millibars, that's the most commonly used one, or inches of mercury, INHG. This goes back to a time when mercury wasn't, well, it was much more common around you. And a barometer in this case had a bowl full of mercury. Mercury is a liquid metal at normal temperatures. And the air pressure pushed down on it, which in turn pushed it up into this glass tube that had all the air sucked out of it, had a vacuum pulled on it. And based on how high it was in the tube, you could measure the air pressure on the outside. Now, we can't have these in school anymore because it's been brought to the, well, medicine has told us, and it is proven fact, that large amounts of mercury inhaled or in your bloodstream and such, they're not good for you. It leads to all sorts of issues, so mercury is outlawed in schools. So we do not have any of these. Now, first interrelationship here. As air temperature increases, it causes the air to expand. When things get warmer, they expand. This goes way back to the first unit we did, I think. And so when temperature goes up, it gets hotter out, the air pressure goes down because the air becomes less dense. So generally speaking, if you have low air pressure, it means you have warmer air. And when you have high air pressure, you have colder air. Soon, well, I don't know if I hope for it, but soon the temperatures will get colder. We'll finally get some real wintertime temperatures. And those cold winter days are often when we have the highest air pressure for the year. Now, in your reference tables, we've used this chart before. We've done conversions when we were reading scales back a couple of months ago. So this is on page 13 in your reference tables, where it has millibars on one side and inches of mercury on the other. And normal air pressure, normal standard average air pressure is 1013.2 millibars. It's labeled on there as 1 atmosphere, or 29.92 inches of mercury. That's normal. So numbers higher than that, if you had 1020 millibars, that would be a high pressure. 990 would be a low pressure. So it's all relative to that 1013.2. Now, this is also in the reference tables. We looked at this not that long ago, actually, when we were talking about ozone and different things being absorbed in the atmosphere in the last topic. We have different temperature zones. And one thing I want you to see on here is that the higher you go, we didn't look at this part before so much, the atmospheric pressure goes down. Because atmospheric pressure is literally just caused by the weight of the air pushing down on you. So if you go 20 miles up into the atmosphere, there's a lot less air above you than there was before. So there's a lot less pressure on you. The higher you go, the less pressure there is because there's just less air to squeeze on you. So that chart is there if you ever need it. Third variable, relative humidity. Now, by relative humidity, you could just say humidity also, and that'd be a different thing. Relative humidity is how full the air is of moisture compared to its capacity, or how much moisture is in the air compared to its capacity. So, is the air half full? Is the air 100% full of moisture? Can it not hold any more? Are you in a desert? Does the air have 10% of the possible water in it that you could have? To measure relative humidity, you use a hygrometer. Now, when I am there, I will demonstrate this for you, but the most accurate and pretty common type of hygrometer is called a sling psychrometer, where you have two different thermometers, and one of them you get damp. You put a piece of fabric on the end and keep it damp with water. The other one's just dry. You swing those around so evaporation happens off the wet one, and you'll end up with a temperature difference. And someone has done the math and figured this out for us, that you can figure out the humidity of the air based on the temperature difference, based on how much evaporation is happening. And it's given as a percent. So these are actually kind of neat. You swing them around, you look like a ninja with nunchucks. You swing them around, cause this evaporation to occur, and you can end up with the number. Now, you are going to have to use page 12 in your reference tables to interpret what the wet bulb and the dry bulb temperatures are giving you, but we will practice that, and it's a pretty straightforward process. The fourth variable is wind velocity. Now, it does not say wind speed. It does not say wind direction. It says wind velocity, because velocity is both the speed and the direction of the wind, because they both do, in fact, matter. In order to measure how fast the wind is blowing, you use a device called an anemometer. They really like this one on the final exam. So anemometer is the spinny cups or propeller-looking blades that might be spinning around and around and around. They're telling you how fast the wind is going to be going. Now, they don't tell you what direction it comes from. They're designed to pick it up from any direction. And they can come in different forms, but anything that's measuring the wind speed is an anemometer. Now, to measure the wind direction, you use a wind vane. Now, it used to be back in the day, every barn that was around had a big old wind vane on top, so you could tell which direction the wind was coming from, a big rooster or something. At airports, you'll often see a, well, they call it a sock, but it looks like a orange tube of fabric that the wind blows through so pilots can see which way the wind is blowing from and how strong roughly. So a wind vane is all about the direction. Now here is a crude animation of the anemometer spinning around and the vane on top lining up with the wind. Looks like the tail of an aircraft, kind of. Yeah, there's an old school, just an arrow that lines up with the wind, so the arrow is free to move around, tell you whether it's north, south, east, or west. You could have a rooster, you could have something lame like a lacrosse player, whatever you want. Anything that can line up with the wind, that could be your wind vane. There's a nice shiny one. So, wind vane and anemometer. There's one combined. It looks like an airplane with no wings. Alright, so which basic weather variable is recorded by each of the following instruments? So, wind vane. What did a wind vane tell you? Wind direction, right? Hygrometer. A hygrometer measures how much humidity is in the air. A barometer is for air pressure. Anemometer is for wind speed, the spinny cups. Thermometer, of course, is temperature. And the sling psychrometer is a specific type of hygrometer, so it's telling you relative humidity. Now, when it comes to weather systems and the weather changing, they all matter, and they're all going to change when weather rolls through. But the single most important one, if I had one choice as far as what's going to tell me how the weather's changing, I would look at the air pressure. Air pressure can tell you about both temperature and moisture content as we look at these variables a little bit more. So a pressure changing is often a sign that the weather is changing as well. All right, I don't think we'll go on to atmospheric moisture, so I'm going to leave you with topic 5B, worksheet number 1 to do, and then we'll pick up with atmospheric moisture next time.